guys, your notes for today are actually titled incorrectly. So if you look on your little weekly schedule, you're supposed to be doing note 16. This is incorrectly titled notes 8. So if you'll just fix that so that everything kind of matches up. Alright, so note 16, your exponential parent function is going to be y equals 2 to the x. Okay, so your center point for graphing is going to be 0, 0. Okay, which is the origin. And then your exponential graph, I don't know if you remember what it looks like, but it has a horizontal asymptote at y equals 0. So I'm going to highlight that on my graph here. This is y equals 0. My graph cannot cross this line. Okay? Then from there, when I plug in 0, okay, remember, I want to find the y-intercept. Okay, well then I'm just going to let x equal 0. So if I do y equals 2 to the 0, anything to the 0 gives me 1. So that means my graph is going to cross through 1. And then on this side, it's going to get really, really, really close to that line. And on the other side, my graph is just going to go up like that. So this side, my graph is going to infinity. But on this side, my graph is approaching 0. So let's talk about our domain and range. Our domain is the lowest that is going to be the farthest to the left that the graph goes, and then the farthest to the right the graph goes. Okay, well think about this graph is going forever and ever to the left, that's negative infinity. This side is going forever and ever to the right, so that's till positive infinity. Or you could put x within all real numbers. Okay, your range is going to be the lowest that the graph can go, and then the highest that the graph can go. So if I'm wanting to do the lowest, how low can this side go? Well, it's going to keep going down and down and down and down and down, but it's never allowed to cross this line, which means 0 is the lowest. However, this side over here is pointed up forever, so it's going till infinity. Now remember that normally I would put for a number a closed bracket, but because this is an asymptote and I never get to 0, I have to leave it open. So the general gist of what we're doing today is you're just going to be graphing these. So your general form is going to be y equals plus or minus, okay, a, b, x minus h plus k. Each of these numbers has a different job. We kind of covered this when we were graphing quadratics back in the fall. So the number in the front tells you whether or not you reflect it. So if it's a positive square root f of x, your graph is going to be like that, just like the one that we drew here. But if there's a negative in front, that is going to reflect your graph down, which means that instead of your graph curving up like that, your graph is going to curve down like that. Okay, so that's your positive e to the, or your 2 to the x, that's your negative 2 to the x. Okay, this number here is going to tell you if you go left or right. Now, when it is a positive h, you are actually going to shift to the left. And when it is a negative h, you are actually going to shift to the right. I know that that's backwards of what you would probably think, but remember, anytime you put it in parentheses with x up here, that changes it to be an opposite. Okay, then your plus k tells you to shift up k units, and your minus tells you to shift down k units. Okay, now notice that for that one, okay, your sign is going to match what you would expect to do. So let's say I'm doing number 1, my center point. Okay, well I need to go to the right 3 because I see a minus 3. Then I need to go up 4. So I'm going to go to the right 3 up 4. That puts me right here. That's my center point, which is 3, 4. Then I'm going to draw in my asymptote. Remember, your asymptote for an exponential is always flat. So it's going to be like that. And then remember that on my exponential graph, this number here is how far up I start from that line. So I need to start 1 above that center point, which is right here. Then my graph is going to curve just like the one that we drew up there. This side getting closer and closer to the asymptote. This side going up forever and ever and ever. Okay, so my asymptote then came out at y equals 4. So I'm going to put that here. Then from there, my domain, I see that I have an arrow on this side. I have an arrow pointed to the right. So my domain is negative infinity to infinity. But my range, the lowest that my graph can go is to this 4 line. Now, it can go as high as it wants, okay, but it cannot go below 4. So my lowest point here is going to be a 4, while my highest point is going to be n infinity. Okay, look at the graph right next to it. Have a +1, that's going to tell me to shift to the left 1. -2 is going to tell me to shift down 2. So -1, -2 is going to be my new center point, which is right here. Then I'm going to draw my asymptote in. Okay, remember for exponentials it's flat. So my asymptote is y equals -2. And then from there I'm going to start at my center point, count up 1, and then you're going to draw your graph. This side, remember, it's getting closer and closer. This side is going up forever. So my domain, this side's going to the left, that side's going to the right, so it's going to be negative infinity to infinity. But my range, this time, my graph can go below 0 all the way to my purple line, which is at a y value of -2. So that would be from -2 till infinity. Okay, also remember that we're leaving our -2 open because graph never touches the y equals -2 line. Okay, it never touches the y equals -2 line. That's how come we're leaving that open with a parentheses instead of closing it with a bracket. Okay, when you're ready, turn over to the back side. Okay, number 3. We have -10, x minus 1 plus 5. First thing that I notice is I have a -1. That means I'm shifting to the right. +1 means I'm shifting up 5. So that's 1, 5. 1, 5 is here. From there, I'm going to draw on my asymptote. Remember, my asymptote is flat across. Boom, boom. Y equals, I drew it in at 5. From there, normally I would put my dot 1 above, and then I would draw my line in just like this. Don't do this. Okay, however, do you notice this negative in the front? That negative changes everything. That negative means that my graph needs to be reflected down. Because there is a negative in front, instead of me drawing it here, I'm going to put my dot 1 below the line, and then I'm going to draw my graph here. So remember, it's the negative in the front that reflects it down. Okay? So this is actually my graph right here. Now, my domain, that side's still going backwards, that side's still going forward, so it's still negative infinity to infinity. But my range now is all messed up because it's supposed to be lowest to highest. And usually that purple line is going to be the lowest point on my graph. But in this case, that purple line is actually the, that should say highest. Oops. Okay, that should be the highest point on the graph. So this side is going to go down and down and down forever and ever, so that's a negative infinity. But then my highest point is here at 5. And then remember, I'm going to leave it open because it was an asymptote, so my graph never actually gets there. Okay, take a look at number 4. Similar situation here. I have a +5. That means I'm actually going -5. Then I have a -2. That means I'm going down 2. So -5, -2 puts me right here. Then I'm going to draw in my horizontal tangent, or my horizontal asymptote. Okay, from there, this number in the front, technically, it controls how far away you're going to put your first dot. So like here, I put it 1 below. So if I have a -2 in front, that's going to stretch my graph to where instead of being only 1 below, it's actually going to start 2 below. But then remember, your thing is going to be the same. Normally, my graph would have been here. Well, then when I reflect it down, my graph is going to be here. Okay, so it's going to be getting really close to the x-axis on this side, and then it's going to be kind of going crazy on the other side down. So my asymptote right here came in at y equals -2. My domain is all real numbers, negative infinity to infinity. But my range this time, remember, I have to go lowest to highest. And I can see that the lowest my graph goes is to negative infinity. This thing's going to go down forever. So negative infinity until the highest point is negative 2. From there, come down to number 5. So now we are going to write an equation. We're starting with y equals x. Okay, it says I want to reflect it across the x-axis, stretch it vertically by a factor of 1.5, translate it 3 units to the left, and then down 10 units. Okay, so my new equation, if I want to reflect across the x-axis, I need to put a negative in the front. Then I have my 2 to the x. Next, I want to stretch it vertically by a factor of 1.5. Well, remember what we said. Okay, your vertical stretch or shrink comes from this number that was in the very front here, like we're at a 2. So if I want to stretch it by 1.5, I'm going to put a 1.5 there in the front. Then I want to go 3 units to the left. Well, remember, 3 units to the left, I actually need to put a plus 3. Because remember, your x is always opposite. And then I want to go down 10, so that's a minus 10. Okay. All right, so all of that is exponentials. Next, you are going to need to graph the function for logarithmics. So all of that's exponentials. Now let's cover logs. Okay, your base for a log is going to be y equals log little 2 of x. Your center point is 0, 0. Okay, this is going to be, oh wait, crap. This is saying to graph this function here. My bad, I got ahead of us. So if I have a plus 3 here, I'm really going negative 3. Then I have a minus 10 here, that's a down 10. So my starting point is going to be negative 3, negative 10 right here. Okay, then from there, my asymptote, I'm going to draw it in nice and flat. Okay, that's barely even on my graph. That's y equals negative 10. So my asymptote is y equals negative 10. Then remember that normally my graph would start 1 above. But in this case, because of the negative in the front, it's going to start below. And because of the 1.5, I would actually start, let's draw in 2 lines here just to kind of help us out with the graphing. Rather than starting 1 down, since it's a 1.5 stretch here in the front, I'd actually go down 1.5. And then from there, my graph would be like that. This side's getting closer. This side's going away. Then my domain would be all real numbers. And my range, my lowest point would be negative infinity. My highest point would be that negative 10. And remember, the reason that the asymptote gets to come second on that one is because negative 10 is the highest it can go. And remember, we're leaving it open because it never actually gets to negative 10. All right, go ahead and turn the page when you're ready. So the last type of function is the log, which I, accidentally had started to graph previously. So your logarithmic parent function is going to be y equals log base 2 of x. Okay, and remember that our exponentials and our logs are inverses to each other. So although my center point is still 0, 0, instead of having a flat asymptote across this way, okay, your log's going to have a vertical asymptote of x equals 0. So your log asymptote's actually running this way. And then your graph is never allowed to touch that line. Now, the other thing that you should know is that, remember, normally on the exponential I started 1 above. Well, for a log, you're actually going to start 1 to the side. Then, as you go down the y-axis, your graph is going to be getting closer and closer. Other side, your graph is going to be curving away from the x-axis. So that's the equation for log base 2 of x. Your domain, think about, okay, domain is your x's. That's the left point and then the right farthest point. Okay, my left farthest and then my right farthest. Okay, well, look at your graph. How far to the left can my red graph go? Once it hits that purple line, it's never allowed to cross it. So my graph can never get past this purple line. Well, that purple line is at x equals 0. Now, as far as going farthest to the right, well, I could do that all day, right? I could keep going and keep going and keep going forever. So it'd be 0 to infinity, open on 0, because remember, my graph can never actually touch here. Okay, second one, I need my range. Well, remember, range is going to be lowest to highest. So look at your graph. When is the lowest point? Well, it goes down and down and down forever and ever. And then what's my highest? Well, it goes up and up and up forever and ever and ever. So you would do it like that. Okay, 3 more left. Take a look at number 7, or number 6. Okay, first thing I notice, I have a minus 3, that means to the right 3. Then I have a plus 2, that means up 2. So I'm going to go to the right 3 and then up 2, that puts me right here. Now remember, for an exponential, I draw a flat log, asymptote in, but for a log, I got to draw a vertical one, so it's going to look like that. And instead of my asymptote being y equals, it's going to be x equals 3 on that. Then from there, my graph always starts one step to the side. And then my graph is going to go down towards the asymptote here, and then curve away as I go up to infinity. So my domain, how far to the left can my graph go? Well, it's going to keep getting closer and closer and closer to the purple line, but it can't ever go past this. Okay, remember, domain are your x's, and so the x of this line is 3. So my graph can never go past 3, but it can go to the right for infinity until whenever. Your range, how low can the graph go? Well, that graph's going down and down and down forever and ever. That's negative infinity. This side's going up and up and up forever, so that's positive infinity. Remember, you could also say that y within all real numbers. Okay, those are the same. Doesn't matter which one you pick. Alright, 2 more left. Take a look at number 7. Number 7, I see a plus 5. That means I'm really going to the left 5. Minus 1 tells me I'm really going down 1. So my start point is going to be negative 5, negative 1. So backwards 5, down 1 puts me right there. That's my center point. Then from there, remember, logs have vertical asymptotes, so I'm going to draw it in. My log asymptote goes like that. And then I'm going to count what x equals. So remember, if it's a flat one, it's y equals, but if it's vertical like this, that's an x equals. And then I see it passes through negative 5. From there, I'd go one step to the side and then draw my graph in. Remember, down towards the graph, it's going towards, up, and away from the graph on the right side. From there, my domain, how far back can my graph go? Well, it can never cross that negative 5 line. So it's negative 5 until infinity. But my range is negative infinity to infinity, because that side goes down forever and that side's going up forever. So I don't have any restrictions on my possible y values. Okay, one more left. Last one like that. Look at number 8. I have a minus 4. That tells me to actually shift to the right 4. But then I notice that I do not have a number here at the back, so I'm going to write it in a 0. So I'm going to go to the right 4, up and down 0, draw my first dot, which is right there. Second step, I need to draw in my asymptote. Remember that from my center point, my asymptote runs up and down. So I'm putting it in here and here. Then remember, from there, I need to start my graph one dot to the right of the origin. So if that's the center point, I got to start at 5. Now remember, don't draw this, but normally my graph goes like that, right? But I have this negative in the front, and think about what that does to all the other graphs. Having a negative in front reflects your graph down. Reflects graph down. So instead of it sharing this shape, it's going to be going towards the graph going up and then away from the graph going down. So this is what it looks like when it's reflected down. It'll look just like this. Okay? Last one like that. Take a look at number 9. Number 9 says my graph is going to be compressed by a factor of 1/2. Okay, well, we know that that goes in the front. Then it says from there it's going to be translated 8 units to the right. Well, if I want to go to the right, then I need to do x minus 8. Then from there I want to go up 12, well then I'm putting a plus 12 on the end. Okay. Alright, so what you should be doing now is taking out your packet. Okay, your packet has all of your assignments for the week, and you are working only on the first page. Okay, so pull out your assignment for the week, and you can do it.